All right, welcome to our final lesson in Unit 5, Exponential Growth and Decay. So if you'll look at the two examples here of an exponential growth and an exponential decay, the models are both the same. They're set up in y equals a times b to the x, where x, the variable's in the exponent. Okay, so the only difference between the two is that b value. Okay, so when that b value is greater than 1, we have things growing, getting bigger. When that b value is less than 1, we have things decaying, or the y values are going to get smaller over time. Okay, so we have two other little concepts. Compound interest is kind of like earning interest on interest. So if you have $100 and I say I'm going to give you 10% interest. So the first year I give you $10, which is 10%, right? So now you've got $110. So the next year I'm going to give you 10% interest, but I'm going to give you 10% interest on the $110 that you have, and so, which is $11. So you're earning a little bit more money each time. So that's what we call compound interest. And then an interest period is the time it takes to earn those interests. So oftentimes when you're talking about interest, you're going to be given an annual rate. So remember, first off, interest rates are usually annual rates. And then there's usually how often it's compounded. So we have to kind of read into those problems a little bit, and we'll talk about them in some of our examples here. So in our first example, we have $1,000 we're going to deposit in a fund that pays 7.2% interest compounded annually. So it's going to be compounded each year at the end of each year. And we want to find the account balance after 5 years. So in order to set these up, we're going to let X be the number of times it's going to be compounded, which in this case is 5 in 5 years. Okay. Y is going to be that an end of the end value, and then A is going to be our initial value. So we set up our equation. It's Y equals our initial value of 1,000, okay, times our interest rate, which is 7.2%. Now remember, we're going to add that to 1 because we want it to grow, okay? And then that is going to be taken to the 5th power there. Okay, so that is how we set up and write this equation. And then when we punch it all into our calculator, we should get $1,415.71 after 5 years of leaving that money alone, not touching it, and earning interest on our interest. Okay, so notice how in this we have our 7.2% is added to that 1, okay, or 100, because we're growing by 7% each year. And again, we'll talk about a lot of these in class and do some more examples. This is just going to be a very quick overview of them, okay? So in our next one, suppose we have that same $1,000, but now the interest is paid quarterly instead of annually. Okay, so here's what we're going to do now. We're going to have that same equation. There's our $1,000 that we're starting with. All right, and now we're going to take that 7.2% interest, but it's compounded quarterly. So that means that they're going to give us a fourth of that, or 1.8% every quarter. Okay, so that's where that 18 thousandths comes in. So they're giving us 1.8% every quarter. Okay, and now instead of having a 5 as our exponent, remember this is 5 years, but we're getting interest 4 times a year. So we're going to put that 20 in there. Okay, and then punch it into your calculator again, and you're going to see that you now get a little bit more money. Not a whole lot. Okay, but a little bit more money because you're getting interest on that interest. So you're getting about an extra $13 for having the same interest rate, just being calculated quarterly instead of annually. And again, we're going to do a lot of examples here in class. So in our final example, we're now going to look at a decay, and we're decreasing our population by 2.4% each year. Okay, so when we try to write an equation to model this, again, we're going to use that y equals our initial of 60 is how many animals we're starting out with, and we're losing 2.25 or 2.4% each year. So if we take that from 1, we now get 0.976. That's going to be our decay factor. Notice how this number here is less than 1. So our population is going to be slowly declining, okay, 0.4% each year, and then that is going to be X is going to represent the number of generations. So in this case, it's each year we're losing that percent of the population. So if this example shows us the number of animals in 1999, okay, then we want to know how many animals are left in 2005. So think about the fact that 6 years have now gone and passed. Okay, so if 6 years has gone and passed, we're going to replace that X with a 6 because 6 generations have come and gone, okay? And then we're going to punch that into our calculator, and we end up getting y equals the 51.86 animals, okay? Now, again, remember, we can't have portions of an animals, so we're going to be left with, after 6 years, around 2005, we're only going to have 51 animals left, okay? So that's how many animals we're going to have at the end of our model that we're looking at for 2005. And again, we're going to talk a lot about these examples in class. This is just a kind of a quick overview. Remember, we're looking at a decay here because this number is less than 1.